This is a training video for IPLCheck AI. IPLCheck AI is a replacement for IPLCheck. Its additional functionality includes direct access to the IBM Health Checker for ZOS, the discovery of, dynamic configuration changes, and the building of baselines that allow for the tracking of changes along the IPL path over time. It, like IPLCheck, is a derivative work of the image focus inspection platform. And so it depends directly on that platform for its input, essentially in the form of an inspection log. Now, the logs are created totally under the control of the IBM Health Checker for ZOS. So the timing and the frequency of the logs themselves is dependent on the timing and the frequency that is set up in the Health Checker itself. So with that said, let me go directly to a demonstration. Shared the wrong thing there. Hold on. Okay, I think I got it right that time. So one of the advantages of image focus in the inspection platform is its ability to discover the makeup of the IPL path and to evaluate that makeup using rule sets that are appropriate for the level of ZOS that is under investigation. As I mentioned earlier, the timing of the execution of the inspections is totally under the control of the IBM Health Checker for ZOS. It in turn creates a log which contains not only the configuration profile, but also the statements concerning the determination that image focus has made concerning the appropriateness of that configuration and whether or not there are any particular risk associated with it. Now, the logs themselves can be daunting. They can run between 20 to 25,000 records long and often cause difficulty during an attempt at exploratory data analysis. Not only is it difficult to find the areas that are of risk, but it also tends to mask the other appropriate information and reports that are included in the log and are often overlooked by users. One of the primary goals of IPLCheck AI is to make the exploratory analysis easier so insights can be gained quickly and to expose those additional items of information that can lead to a better understanding or can lead to more appropriate disclosures for auditing and compliance purposes. Now, like other components that are derivative works of image focus, like ZTuneUp AI, a license key is necessary in order for you to proceed to the primary menu. The key, which is available from technical support, will be entered from or be entered in the NSE PRM member, and then once entered, access is through the TSO command line. Unlike access to reports and other inspection components of image focus that are controlled by the creation of a VTAM application. So this is purely TSO. So at the command line, because we're going to launch a TSO command, we're going to type TSO $ command line interface, comma, asterisk, CK IDE. Now, the primary menu will appear as a dashboard. And the reason that format has been adopted is because another advantage of IPLCheck AI is its ability to look across a broad range of image focus inspection logs and present them as these little vignettes, if you would, in this panel, up to 32 at any given point in time. Now, the information that's presented here is brief, but it's intended to attract your attention in those instances where things might be of importance to you. So, for example, we can see here that there are differences that have occurred in dynamic changes, so that's diff. There's some that remain the same, some are different, et cetera, et cetera. We can see the number of errors, warnings, and notices that are available within the logs themselves. And if the information is available, the date when the log was actually created. Now, this is a development system, and so some of these dates are going to appear historically old, but nonetheless, you should be able to derive the specific meaning from them, that they are valuable bits of information that show us when the inspection was last run, that is under the control of the IBM Health Checker, and what the finding actually was. Errors, the first digit, warnings, the second digit, and notices, the third digit. There are system names that are shown up at the top of each vignette. So ENOX, SysB, SysE, et cetera, et cetera. Those are the system names that are actually under inspection. They show up in white. The system that's actually running, in this case SOW1, is shown in green. And in addition, there is an opportunity to establish what we refer to as a gold system. That is one that can be used as a continuous baseline for comparison purposes across all of these systems in order to identify configuration drift that might be occurring between systems or from one system to another system over time. We can put the cursor under the image name, so in this case SOW1, and press enter. And here we'll expand the vignette into a full dashboard of results that were determined from the inspection log itself. So this is the date when the last inspection log was created by the IBM Health Checker's control of image focus. This is the time. This is the age of the log. And this is the release level that was in place for image focus at the time that log was created, 19H28. This is the name of the log, and we can put the cursor under that and press enter, and we'll see the log itself. And if I page down here, I'm getting there. We can see that in this particular case, this log is 18,288 records long. Development system, not a particularly big log, but these can be as much as 25 to 30,000 records in length, of course, making it somewhat difficult to do exploratory data analysis. Press PF3, and we're back to the dashboard again. We can look at the weights that have been put in place to ameliorate, if you would, certain inspection findings that you may be in disagreement with. For example, in this case, we have 1, 5, 6, 7, 8 in, image focus 5, 6, 7, 8 in. And we want to promote that, if you would, to an error. And so in order to do that, we have a syntax that allows us to do it within a specific image focus pawn line member. If I hit PF3, I can actually see that member, or at least parts of it, to see whether or not I want to go ahead and begin an update. I would put the message, I would represent it, I would put the text. I could do just about anything I chose to do just by updating the weights of the inspections that I'm interested in. If I want to see all of the messages, I could do this. So I might choose this one. Protection inadequate. There was one such message. It was the first one in the group, and there was one of them. And so let's PF through that. I can put that on the message line. I can decide that I want to change that to an error. Oops. Where'd you go? There you are. And if I want to make it active, I just put a check mark in the front of it. Now, if I also want it to also identify not only this message and the fact that it's a warning, but I also wanted it to identify some specific text. Let's go back and take a look. For example, this. And I can put that text on the line. And so now, in order for this message, the W, to be changed to an E, it not only has to match the message with the warning, but it also has to match the text, protected, not checked. There's also another option here. If we choose to do it, we can replace the text if we want to. We could say something entirely different. We could say, find this message, and when you get to its text, say, this is okay with me. And from that point forward, when that particular message is discovered and displayed or, excuse me, generated by image focus, it will replace that original text with this text and proceed accordingly. You can update the weights. So it's detected some changes. It's asking us if we want to update. Yes, we do. It's giving us some examples of things. And now we have detected things here. Here are the old ones that we have in the system, which have all been commented out. But now we have this one, which allows us to see that our work has been posted into the NSE MSG, in this case SA, image focus pawn line member. Notice it shows us that we're adjusting weights have been updated. It tells us the program that did it. It tells us the user and the date and the time when that update was actually taken. So from this point forward, that update will be in place. So changing these weights is essentially like changing the weights in a large language model. The model itself, that is the one that's being run by image focus, is referred to as a rule-based retriever, meaning that our data scientists actually trained it on specific ZOF rules, their experience and the experience of customers. And what we're doing here is we're saying we're going to override that rule. We're going to change the weight or the bias that's associated with it in order to provide an answer that is more appropriate for the inspection of our particular configuration. Each configuration can have its own bias if you wanted to. Each one can be different. We can search here if we want to for specific data sets, members, user IDs, and messages that are contained in the log. For example, a user ID, PHAR1, and it'll come back and it'll tell us all those places where it was able to find a message ID that was similar to that. As we go down further, we can see the current finding. So this is the finding from this log, so we can go directly to those messages. Here are the 13 different notice messages. You don't have to go to the log itself, they're displayed here. And we can check to see if anything has changed from the prior inspection, which is shown here as the last inspection finding. So nothing has changed. We can see that we have a backup, so we know that in this particular instance, this system is working in concert with the control editor to make sure that we have a constant, consistent backup of our IPL path configuration. We can look at history. That will give us the history of any configuration changes that have taken place. So this particular one goes back to June 16th, and you can see the changes that are taking place here, not only in the inspection, but also in dynamic changes, changes to system symbols, APF, BPX, etc., or changes to the configuration itself. If there have been any, they would be shown here. So it's a little history chart that can bring you up to date on how things are progressing over time. If we PF3 back, we can see that the current IPL was taken on December 27th, 2005. We can see the time, how old that is, and what release level that we're currently looking at, V2R5. We can see the unit address, load, IODF, and the load member. We can see any changes that might be taking place in the dynamic changes. So if we want to go look at LPA, we can see what those 5 changes are. We can see where those LPA members are contained if we want to go and change them. So IEA LPA 00 or LPA list 01. So they're in either one of those two. We can look at the health checker and what the checks are that are associated with it. So it has 3 high checks. And here they are. If there was a history available, we would be able to see that, but in this particular instance, there is no history available. And we can see all of the particular checks here, high, medium, and low as well. See the severity, when it will not run next, who the owner is, and what the check name is. More detail on that if you are in need of it. So here's a panel that will show us more information about a particular check, allowing us to drill down into the actual check itself. So here it is in this case. So you can see there's tight integration between the inspection process, which is under the control of the health checker, but run on demand by image focus and the processes that are run by the health checker itself to determine whether or not it might discover any concerns that are a high, medium, or low nature, as the case may be. There is also additional weight adjustments that relate to the dynamic changes, again, link, LPA, etc. Here's the current list as it exists and was applied. And you can see here that the list is as you defined it, NSE LPXSA, the module name in this case. But the asterisk in the front of it indicates that, in fact, we did make a match on that and that it has been excluded from the report. These at the bottom, RACD cert and RACD cert 1, are in the list, but they are not preceded by an asterisk, so that indicates that they have not been eliminated. We can, if we choose to, we can view the current excludes. This is as they exist in the dynamic change report. We can update NSE LPXSA. No dynamic updates were detected. So there was nothing really to do. We've already taken care of all of those, so there's really nothing more for us to do. We can check to see when the last time a baseline was taken, 8/24/26, at what time it was taken, what the name of the baseline is, and whether or not we have any specific changes. The items that are shown below are essentially discovery prompts. That is, they are prompts against the AI component that is helping with exploratory data analysis to fetch from the inspection report, the log, specific reports. So for example, if we needed to see the data set report, you can just press enter, put a cursor under it and press enter, and we'll see that report displayed on the screen. So sometimes these reports are overlooked. Prevailing keywords and values shows us things like the keyword name. These come from IEA-CIS, how it was defined, default, but what is the default? 00, APF default, but there is no default value. AUTOR, it has two suffixes, 00 and AG, and this continues on down. Tells us the member that they came from, if they aren't defined by default, in this case, IEA-CIS WS. Prevailing members and the findings associated with them. So you can see the member name here, IRR or PRMVS was spec'd in IEA-CIS WS. It's at level 0 in the concatenation. It was last changed on this date, and this is the user ID who actually changed it. You see this one, PROGCM, also spec'd in WS. It has a notice in it, and it's at level 1 in the or level 0 in the concatenation, and it was last manipulated by PRL2. And this just goes on and on and on. The program property table often asked for by auditors. This is a decoding of the IEF SDPPG, or member that comes from IBM as a standard part of ZOS. These are components that they want to have excluded from testing BioRASF. And so it's often important to make this available. Gives you the name of the member, whether it's set at cancel or not cancel, what key it's operating in, whether you can swap it or not swap it. If you choose to, you can print, copy, and email any of these reports. If I click email, and then I click Common System Storage, I'll get the storage report, but when I PF3 out, I'll drop into an email screen, and this email screen allows me to send a message to a group of individuals with a certain subject, and to send it in a number of different ways. I can send it as SMTP, Security Server SMTP. If I can give it the writer name and the class, and if I have that set up, and the ENS member support can help you with that, then you could send this email now. Of course, assuming that email is an allowed method of communication within this specific LPAR. And of course, if I chose copy, and I chose IPLCheck members, when I hit PF3, I would see the move copy utility, and then I could use that to print a copy of that particular report. If I want to establish this particular inspection configuration as my goal baseline, I would just put the cursor under goal and press goal. And now it's already there. So if I choose to, I could remove it now as the goal baseline, or I could just hit PF3 and abort it. And I just did that. So this essentially takes us through drilling down into any one of the specific configuration. But other things that we can do is we could compare the current configuration against the goal configuration to see if there are additional risks that might have developed over time since the goal baseline was first established. And we can see in this case that there is no change between the two when it comes to dynamic changes. And there are no changes that exist when we compare it against the risk associated with errors, warnings, notices, and anything that we would consider to be a heads up. We can do this repeatedly. We can compare SOW0 against our current running system. And we can see that we have a number of different changes in this case. If we put the cursor under one of the differences, in this case, a 5 for warnings, it will tell us what those 5 additional warnings are that were in SOW0 that are not in SOW1. So they were all APF dataset protection errors that are no longer a risk in the current configuration, at least in comparison to it. There was one LPA change, and in SOW0, there was a number or a module name of this that was in the configuration that is no longer impacting a comparison with the current configuration. The logs are here, so we can always go see them. We can always do a search. As we did from the prior panel. The date up at the top, in this case 13/22, represents the starting point of this particular session. If I choose to, I can put the cursor under that and press enter, and it will update the panel and its findings to make sure that there haven't been any recent log updates that have taken place since I first entered. So now we're at 13/47/17. Up at the top, this shows us the name of the application and when it was first put into service, so in July the 9th. This shows us the name of the model that was used to create the goal, or the name of the image that was used to create the goal model. If we put the cursor under exceptions, what we'll see here is a real-time update to the exceptions that are reported by the IBM Health Checker for ZOS. Now, in this particular instance, this development system only has one active system within it that's under the control of the IBM Health Checker for ZOS. But if there were multiple instances of control under the IBM Health Checker for ZOS, they would all appear here, and then you could perform essentially the same analysis, that is, comparing the current system against, for example, the goal system to determine if there had been any changes. And it comes back and it says, yes, you have some changes. The goal system said we have 11, now we have 3. Mediums are the same, this is a little different, et cetera, et cetera. We can go take a look. We can see what those are. Most of these are problems that existed in New Era checks, Telnet, Pageant, IP Complete, et cetera, that are no longer a problem in the current health checker configuration. We see it up here as a total number of checks, and we see it down here as represented as a total number of risks. Moving on to show the baseline changes. Now here what we're doing is we're comparing the baselines for all 15 of these images against their current state. So this will take just a few seconds in order for it to complete. Certainly be a lot faster on your machine as opposed to the ZPDT that I'm operating under. So here we see the results. It's essentially the same format as the prior 2 dashboards, little vignettes that give us a better understanding of what it was actually finding during the discovery process itself. If we put the cursor under SOW2 and press enter, we'll see a panel that gives us an opportunity to explore the changes that were detected. So we detected one change. Here it is. So we can see 2 things were deleted. We can see the current member configuration, where it was found, what its update status is, etc. So that's the full content of the member. We could see those that were deleted, those that were added. So it does that for all 15 of these. And that gives us some opportunity to understand changes that are impacting one image that might not be impacting another. We, of course, can compare the images here if we choose to do it. So I'm going to compare the gold image against SOW1. No configuration changes were actually detected here. So there are 69 members. There are 0 member changes in SOW1. Has not, gold has 0 changes that relate to SOW1. So this is a Venn diagram analysis, if you would, that lets us compare one configuration against another. If we go back and now we compare these two, we should see some changes. And we do. So in this instance, 5 of the configuration numbers in SOW2 match with the configuration numbers in SOW1. On the other hand, these are different. We have 61 that are actually common. If we put the cursor under Show Difference, it will list those members in this panel, up to 72 as possible, so that we can now take a look at what's different between the two. So in one case, SOW2 showed time zone as being 08, and in SOW1, that was deleted. In SOW1, it now shows the time zone as being 07. And we can continue on down with that. You can see an error and a warning were deleted from the findings themselves. So we're not only looking at the member content, but we're looking at the state and status of the member as it appears in the configuration. I think we saw this one, IEAC 00 already. And this one has a new message in it. This was added. Sysres appears to be a secure boot volume. So the first one was not a secure boot, and this one is a secure boot. So that's pretty much it. 3 different configuration access points that are not fully supported under the old version of IPLCheck that give us access to dynamic changes, to the IBM Health Checker for ZOS, as well as access to baseline configurations that can be used for comparative purposes to track changes and drift over time. Just PF3 back. We'll finally get to a panel that says, if you choose to PF3 again to exit, I'll return to continue. So I'll go ahead and exit. So that brings us to the end of this training video. I hope you enjoyed it. Please let me know if you have any specific questions. I'll be glad to answer them for you. Take care. Bye-bye.